In early 2020, educational systems worldwide were forced into an immediate, unplanned experiment. Millions of classrooms moved entirely online overnight. The initial assumption was that educational technology and artificial intelligence would streamline this transition. Administrators expected these tools to automate repetitive tasks and optimize the flow of information from teacher to student. But academic studies tracking educators in real-world hybrid environments, such as the Arab communities in the Negev region, revealed a very different reality. Instead of optimized efficiency, researchers documented a massive spike in teacher burnout. Educators experienced severe cognitive overload and systemic friction that ground daily instruction to a halt. This creates a paradox. Why do digital systems explicitly engineered to simplify data transfer end up multiplying the mental and administrative burden on the person running them? The answer lies in a structural error. Institutions treated powerful digital networks merely as new delivery pipes for old, linear teaching methods. Surviving this digital shift requires abandoning the idea of the teacher as a one-way transmitter of facts and structurally rebuilding the role entirely, transforming the educator into an architect of learning experiences. The traditional classroom model relies on a single fragile premise: localized, synchronous attention. Everyone is in the same room, at the same time, looking at the same person. We can visualize this traditional pedagogy pipeline as a linear flowchart. Information flows directly from the central teacher, through direct instruction, straight to the student, and terminates in a final exam. But as this diagram shows, when we introduce the hybrid variable, simultaneously managing physical students in the room alongside virtual asynchronous learners, that straight line fractures. Qualitative data shows teachers struggle severely to distribute their attention across these two competing environments. They experience a phenomenon known as hyperfocus. The brain is overwhelmed trying to monitor digital chat boxes, assess physical room behavior, and troubleshoot audio glitches, all at the exact same moment. This split attention dynamic actively destroys interactive equity. Students in the room get one experience, while those on the screen get a diluted, fractured version. In a purely physical space, teachers rely on natural social cues, a confused look, a shifting posture, to gauge understanding. Over a screen, those micro-expressions are compressed and lost. Without changing the underlying pedagogical structure, the hybrid model forces a single human brain to process an impossible volume of synchronous data. Cognitive overload is not a failure of a teacher's willpower. It is the mathematical failure of a linear pipeline attempting to process complex, nonlinear inputs. To fix this, the broken linear pipeline has to be replaced by a decentralized hybrid ecosystem. This hub-and-spoke diagram illustrates the new model. The teacher sits at the center, but no longer as a unidirectional broadcaster. Instead, they act as a routing hub, connecting students to different learning modalities. The first pedagogical strategy required to make this ecosystem function is the flipped classroom. By moving rote direct instruction to asynchronous digital video or text, material students review on their own time, the teacher removes the burden of lecturing from the live session, drastically reducing their synchronous cognitive load. The second strategy is digital collaborative learning. Rather than passively watching screens, students use their digital devices for active peer-to-peer engagement right inside the physical classroom. This model reallocates resources efficiently. AI and digital platforms take over the mechanical transfer of knowledge and baseline grading. This frees up the teacher's synchronous time to do what algorithms cannot: provide psychological support, guide complex problem-solving, and execute targeted interventions. Operationally, the classroom transitions from a space meant for passive listening into a laboratory for active application. True digital pedagogy uses technology to automate the mechanical tasks, deliberately reserving human energy for high-value human interactions. Within this new hybrid ecosystem, the most critical and most misunderstood node is assessment. Traditional pedagogical methods rely on the rigid, terminal, end-of-term summative assessment, a single test designed to measure months of learning all at once. In a hybrid environment, summative assessments fail because the feedback is too delayed. Without the constant visual check-ins of a traditional classroom, a teacher might not realize a remote student is lost until after they have failed the course. The required replacement is continuous formative assessment, evaluating student comprehension in real time through ongoing, low-stakes activities. We can see this in action through this data feedback ring. This model is powered by AI predictive analytics, which continuously analyze both a student's academic performance and their behavioral data, like login frequency and assignment completion rates. This real-time data stream allows teachers to identify at-risk students immediately, rather than discovering them after a final exam failure. The output of this constant feedback loop is a highly personalized learning path that adapts dynamically to an individual student's pace. In the digital classroom, assessment transforms from a retrospective judgment of failure into a real-time navigational tool for success. Conceptualizing this ecosystem is one thing, but operating it requires the educator to master a specific new set of functional competencies. The first pillar of this matrix is digital competence. Digital competence requires the ability to integrate hardware seamlessly into a lesson and possess the technical flexibility to troubleshoot failures in real time. And the second pillar is pedagogical design. Teachers must develop the architectural skill to deliberately structure a curriculum, properly balancing asynchronous independent work with live synchronous collaborative time. The third and most critical pillar is socio-emotional leadership. Remote learning itself can be profoundly isolating. Educators must actively build trust, maintain clear lines of communication, and guide students through the psychological friction of remote learning. An educator's effectiveness now depends entirely on their mastery of this three-pillar competency matrix, rather than their ability to simply recall facts. When we zoom out and look at a fully realized, optimized hybrid pedagogy ecosystem, we see a network running at peak efficiency. It stands in stark contrast to the chaotic, bottlenecked linear pipeline that collapses under the weight of synchronous data. In this ecosystem, we see that artificial intelligence and these new hybrid environments absolutely do not diminish or replace the teacher. By stripping away the rote, mechanical aspects of instruction, technology actually elevates the uniquely human elements of education, empathy, complex reasoning, and mentorship to a premium. On a macro level, institutions cannot simply purchase new software and hardware and expect immediate results. Educational systems must implement systemic, ongoing professional development that focuses heavily on pedagogical design, rather than just basic tech support. The future of education relies on recognizing a simple fact: technology is merely infrastructure. It is only ever as effective as the human systems deliberately designed to wield it.